Hello and welcome back to Dr. Logic awkwardly does logic and finally begins to do something exciting and interesting again. In this video, I'm going to introduce you to the test. This is something that we will be putting our various formulas through the paces of, the results of which, if we have something that passes the test, we will be able to generate a proof of it in S5 and conclude that it is a theorem. And if it fails the test, we will use the way in which it fails to generate a counter model to show that it's not a theorem of S5, because you can make it false on at least one S5 frame. So this is very exciting. The test relies very crucially on the fact that formulas in OMC and F have a particular type of structure. We will exploit that structure by using bits of it to form new disjunctions, which we will then test to determine whether they are tautologies or not. If we get tautologies in the right places in our formula, then we will pass the test. If we don't get these tautologies, we will fail the test. So that is a very kind of abstract view of what's going on. Getting the details of the test, it's one of these things where the test is actually really hard to write down, but very easy to do. So I will give you the written definition, but then we'll go through some examples, and that will make it a lot more straightforward what exactly is going on. But let's get the details first. So bring up the whiteboard. We're going to start from a very basic arbitrary formula. So let phi be a well-formed formula that is already in ordered modal conjunctive normal form. Now, we already know that it has a particular shape because every formula in OMC and F has this shape. So this is just to kind of remind you, note that every well-formed formula in ordered modal conjunctive normal form is of the form C1 conjunction conjunction CK, where each of these CI ranging from 1 all the way up to K is itself a disjunction of the form beta or necessarily gamma 1 or necessarily gamma n or possibly delta. So this is the general structure of these. So there could be only one conjunction, there could be multiple conjunctions, however many there are, they all have this format. Each of these kind of disjunct slots could itself be empty. So you can have something that fits the modal conjunctive normal form, even if it doesn't have the purely propositional part, or it only has one possibility, or sorry, one necessity disjunct, or it doesn't have any possibility disjunct, or it doesn't have any necessity disjunct. So any one of these combinations, including having 0, is acceptable. But what we're going to do is for each one of these conjuncts, each of which has a form that looks like this, we're going to pair bits of it up and then test to see if the result is a tautology or not. So for each CI in our initial formula phi, we will form up to, and possibly including, n plus 1 disjunctions. So this will be n if the conjunction that we are looking at has no purely propositional part. It'll be n plus 1 if CI does. So we've got n of these gammas, and then if we also have a beta, we will end up with n plus 1 disjuncts. And we will form these disjunctions by taking delta, so this bit that is possible, and disjoining it to each of beta, gamma 1, up to gamma n. So we will get things like beta or delta, gamma 1 or delta, dot, gamma n or delta. So these are all of the disjunctions that we are going to form. Now, these are the things that we will test. So this conjunct CI, we will say passes the test if at least one of these disjuncts is a tautology. So at least one of the resulting disjunctions is a tautology. And then it fails otherwise. So if none of them are, then that conjunct will fail the test. So we do this for each one of the conjunctions separately from each other. And if all CI in phi pass the test, then phi passes the test. If at least one CI in phi fails the test, then phi itself will also fail the test. So, as I said, this is kind of a strange definition to write out, and it will become much more clear once we start going through examples, just as the reduction to first degree, conversion to ordered OMC and F, having an actual example will make it much clearer what is going on. So in the next video, we will begin testing conjuncts, testing formulas, seeing what passes, seeing what fails. Ah, what fun. And then after we've gone through some examples of that, we can then look at, okay, how do we use this information to either prove theorem hood, create a counter model, all of that good stuff. But all in good time. You don't have to rush. Take it easy, and I'll see you next time. Until then, take care.